In this next set of questions, we're going to be looking at graphs of quadratic functions. Find all x-intercepts of the graph of f of x equals x to the fourth minus 15x squared minus 16. Now remember, an x-intercept is where the graph crosses the x-axis, which means that the function value has to be 0. So really what we need to do is solve 0 equals x to the fourth minus 15x squared minus 16. This is not exactly a quadratic equation, but if we let u equal x squared and u squared equal x to the fourth, we can substitute and get 0 equals u squared minus 15u minus 16. And this we can factor and solve. This would be u minus 16 times u plus 1, which would mean that u minus 16 would be 0, means that u has to be 16. Or if u plus 1 is 0, a u would be negative 1. Now it's tempting to stop here, but whenever we make a substitution for another variable, we need to resubstitute back for x. Since u is x squared, we have x squared equals 16, or x squared equals negative 1. When we solve this, we would get x equals plus or minus the square root of 16. So this gives us x equals 4, or x equals negative 4. Here we would have x equals plus or minus the square root of negative 1, which would give us x equals I, or x equals the opposite of I. We have 4 solutions of the equation. However, we're not asked for solutions of the equation, we're asked for x-intercepts of the graph. When we have an imaginary answer, this is not going to give us an x-intercept. It's not going to show up on the graph as a place where it crosses the x-axis. Only these numbers, the real numbers, will correspond to x-intercepts of the graph. We need to write the x-intercepts as ordered pairs, so we can say the x-intercepts of the graph are 4, 0, and negative 4, 0.